this question here on page 28 of the Calculus 2 notes. We'll take a look at it and we'll go through how to go about doing it. So for this one, it says in question 3.13, we are finding the turning points. So we know turning points, that is where our first differentiate will equal 0. We have our curve there and it wants us to determine the nature, okay? Which means that we're going to need to check, and see which is max and which is min. So we have our 3 steps when we're doing a question like this. Our step 1 is we're going to need to get our first differentiate equal to 0 and solve. So our first step there, my first differentiate is going to be 3x squared minus 18x plus 15. And because it's a turning point, I equal it to 0. And this is what I'm now solving. To solve something like this, I'm going to do minus b formula. When I do my minus b formula, I get 2 values, x equals 1 and x equals 5. So now we've done our first step there. Let f of x equal 0, left the first differentiate equal to 0 and solved. Our second step then is, because we're looking for turning points, maximum minimum points, we need to now fill the values for x into f of x, and that's going to get us y. So my second step here, there's my step 1. My second step now is to go and get the y coordinates. So to fill in the y coordinates, I'm filling in my original function, and I'm getting y is equal to 1 cubed minus 9 times 1 squared plus 15 times 1. And when I fill that in, I'm getting my y coordinate to come out to be 7. So that is when x is 1 and y is 7. The second one then I got was for the 5. So I now have 5 to the power 3 minus 9 times 5 squared plus 15 times 5. And when I fill that into the calculator, I'm getting minus 25. So that is the coordinate where x is 5 and y is minus 25. So there's my second step done. I now have 2 points. So one of these is a maximum point, one of them is a minimum point. They're both turning points, but we now need to do our third and final step. So to test which is max and which is min, we are now going to fill in our x values into the second differentiate, because the second differentiate determines, are the slopes decreasing, are the slopes increasing, is the rate of change of the slopes positive or is it negative? So our third and final step means I need to get the second differentiate. So that's going to be differentiating this here. So when I differentiate that, I'm getting 6x minus 18. My coordinates are 1, 7 and 5 minus 25. And remember, we only fill the x value in because we only have space for an x value. So my second differentiate, when I fill 1 in, is going to be 6 times 1 minus 18. That's going to be 6 take away 18, which is minus 12. And when I fill in my first differentiate in with 5, I'll get 6 times 5 minus 18, which is 30. Take away 18, which is going to be 12. Now remember, the minus 12 and the 12 don't make any difference, not the numbers, just if it's a plus or a minus. Minus 12 is less than 0. Less than 0 means that we have a maximum point, and the maximum point is at 1, 7. Here, because my 12 is greater than 0, that's greater than 0, that tells me I have a minimum point, and the minimum point is at 5 and minus 25. So that is determining the natures of those. The last little bit here, it says to find the turning points, we use our first differentiate equals 0, which is what we know anyway. That was our first step. So there's our first question. Moving on to our second question again, it's asking us to find the turning points. So I know turning points are where my first differentiate equals 0. Determine the nature of these turning points. That's, are they a max or are they a min? So this again is going to use our 3 steps up the top. So our first step there is to find the first differentiate and let it equal to 0. So my first differentiate is the differentiate of my function there, the y equals. Remember, y and f of x mean the same thing. So I have 3x squared minus 12x minus 15. I'm looking for when that equals 0. So this here is what I'm going to use my minus b formula with. And when I use my minus b formula, I'm getting two values there. I'm getting a -1 and I'm getting a 5. There's my first step. So I have found my x coordinates because they're points. My second step, I need to fill x into the original because that's going to find me my y values. So here I'm going to fill in my -1. So if x is equal to -1, I'll have -1 cubed minus 6 times -1 squared minus 15 times -1 minus 3. So my y coordinate there turns out to be 5. So that is the coordinate -1, 5. The second one is where x is equal to 5. So again, I fill in my original function to find my y coordinate. And when I check that in the calculator, I'm ending up then getting -103. And that is the other coordinate then, 5 and -103. So what we have here is we have two turning points. One is maximum and one is minimum. Now we need to determine their nature. So to determine their nature, I'm going to fill my x coordinates into my second differentiate because the second differentiate tests which is max and which is min. So my second differentiate there, which is max and which is min. Now my second differentiate is I differentiate this again. So if I differentiate that, I get 6x minus 12. So my first coordinate then is -1 and 5. So I'm going to have my second differentiate is equal to 6 times -1 take away 12. It's going to be -6 take away 12, which is going to be -18. I fill in my other coordinate as well, the 5 and the -103. And remember, the 5 is the only number that's going to go in because it's only a space for an x value. And I end up there with 30 take away 12, which gives me 18. And remember, the -18 and the +18, the values don't matter. All that matters is that this is less than 0 and this is greater than 0. If it's less than 0, we have a maximum point, and that maximum is at -1, 5. And if it's greater than 0, we have a minimum, and the minimum point is 5 and -103. So that's our maximum and our minimum. The last stage then with these questions is to look at the point of inflection, which will be in our last video.